Hi students, good morning. Today we are talking about a new concept with inorganic chemistry. Here, today we are talking about that particular concept, especially the concept is appear in fourth A group elements, fifth A group elements, sixth A group elements, friends. Okay, and now that is the properties related to the top, especially carbon atom. Now here the property name is the catenation property. Okay students. And now it is the catenation property. So that is catenation. Actually what is meant by catenation? Now here catenation is defined as the self linkage of atoms with other elements through covalent bond formation is called as catenation property. Okay friends. Now once again catenation is defined as the self linkage of atoms with other elements through covalent bond to form a long chains and cyclic compounds and branched compounds. So this is known as the catenation phenomena. Okay friends. So this is the catenation property. Now here self linkage of atoms. Self linkage of atoms with itself. For example, self linkage of atoms with itself means now you have to take a carbon element. So this is the carbon element. Now what is the self linkage of carbon here? That means the carbon element which is bonded with number of times same type of atoms. Okay, so this is called as catenation phenomena. Okay, students. Now here catenation indicates or catenation describes the self linkage of atoms with other atoms through covalent bond formation. Now here this is the carbon atom. Now this one is one sigma bond, sigma bond, sigma bond, and here should be the sigma bond. The same element which is bond with another carbon atom. Now this is connected with another carbon atom. This is connecting with another carbon atom. This is connecting with another carbon atom. This is connecting with another carbon atom. Okay. Now such type of linkage is known as catenation linkage or catenation property. Now here, now due to the catenation property, it can forms that long, okay students, long chains of compounds, long chains of compounds. Okay. And the next one, it is able to form that rings, number of rings. Okay. And the next one is branched compounds or branched chain compounds. So these type of compounds are formed by that catenation. Okay, when the catenation is present, now it can forms or it can produce the long chains of the compound should be produced by the catenation, and rings should be formed, and the branch chains also formed due to that presence of catenation phenomena. Now here it is the very important property. Now that depends upon the catenation, it can form that number of compounds or millions of compounds. Actually it depends upon the catenation property. Carbon has a carbon valency, the tetravalency, it has 4 valence electrons. Due to the presence of 4 valence electrons and next to the tetravalency, it is able to form that millions of organic compounds. Okay students. Now we will study about this catenation property in the fourth A group elements. Now first of all you should take that fourth A group elements. Now here fourth A group elements means first of all carbon element and next one the silicon, carbon, silicon, and next germanium element and tin element, next one the lead element. Okay students. Carbon, silicon, germanium, tin, lead. So these are the fourth A group elements. Now in these case carbon undergoes, that means carbon has the highest catenation property. Okay, now carbon has the highest catenation property. What is the reason? Carbon only having the more catenation tendency. That means now the bond dissociation energy is bond dissociation energy of carbon is very high. So that's why it has the more catenation property. Okay, students. Now the bond dissociation energy of carbon is equal to 348 kilojoule per mole energy is there. Okay, now it one is the 180, okay students, kilojoule per mole. Now this one is the 167 kilojoule per mole energy. Now it one is the 155 kilojoule per mole energy is exhibited. Now the bond dissociation energy of this one is the, now here actually it is the 150 kilojoule per mole, but in some books 0 bond in target. Okay students, now the now in these cases, that means in these elements, the which element has the more catenation property, or which elements able to form the more bonds. So that will be the catenation properties depends upon that only in bond dissociation energy or bond energy. Okay friends, now here it is depends upon that bond energy. That means the amount of energy is required to break the bond. Okay friends, so this is the bond. Okay, now in between the bond it requires that so for the breaking for this cleavage of this bond, it needs the 348 kilojoule per mole amount of energy is required. Now that's why now it has the more catenation tendency. Okay students, now top to bottom in a group. So what happens here? Now that means actually here carbon, silicon, germanium, tin, lead, in these groups the bond dissociation enthalpy, the bond energy, okay, bond breaking energies decrease from top to bottom in a groups. And one more thing is the lead can form that this type of bond formation in between the lead. Okay students, now SN also same, but here it has the very less bond dissociation and very less bond energy. Okay students, so that's why bond energy decreases. So that means catenation property also decreases. Okay students, catenation property also decreases. Now here you have to take that carbon. Now that means here the carbon bond and the bond energy is the 348 kilojoule per mole. So that means higher the bond energy. Okay, now that one is the greater the catenation property. Okay, now when top to bottom bond energy decreases, now at the same time catenation property also decreases from top to bottom. So this is the general phenomena, or this is the general concept of that catenation phenomenon. Now what is the importance of catenation in the chemistry? That means actually now in our total organic chemistry, now that should be depends upon that only self linkage of atom of carbon. Okay students, now it can forms that what type of compounds here? Self linkage of atoms. So it should be the catenation property also completely depends upon that bond energy. So greater the bond energy, greater the catenation property. So when the bond energy decreases from top to bottom, now the catenation property also decreases from top to bottom. Okay students, so this is the catenation phenomenon. So due to the catenation property, now the carbon can form that open chain compounds. Okay students, like this open chain compounds. Okay, and carbon can form that branched compounds. So that means it can form that different type of branches. Okay students, and carbon is able to form that cyclic compounds. Okay students, now it can form that cyclic compounds. Due to the catenation property, carbon is able to form that, or able to produce the longer chains, and next the branched chains, and next one is the cyclic compounds, and it is able to form that multiple bonds. That means double bond containing compounds, and next the triple bond containing compound. So this is the phenomena of that catenation property. Now now we will check that catenation property in group 16th 15th group elements, and next is the 16th group elements. Okay students, so here the catenation energy of this one is the, that means the catenation property of this one is the carbon is more catenating than that silicon. Okay, which is more catenation than that of germanium. Its catenation property is equal to that of lead element. Okay, sorry, now here it is the tin element. Okay, now this is the catenation property order. Okay, it is able to form the more bonds than silicon, which is able to form the more bonds than that germanium. Now germanium and tin can form the same type of bonds. Okay students, so this is the catenation phenomenon. And next one is the, now we will check this catenation property in that 50A group elements. Okay students, 50A group elements. Now what are the 50A group elements? Now here we know 50A and next is the 60A group elements. First of all, we study the catenation property in the 50A group elements. First we will take the nitrogen element, and phosphorus. Okay, students. Nitrogen, phosphorus, and next is the arsenic, and next is the strontium, and last one is the bismuth. Okay, so these are the fifth A group elements. So these are the fifth A group elements. Now here, first of all, we want to study about that catenation property in these elements. Now first we have to compare that catenation property of fifth A group elements with that fourth A group elements. Okay, students. Now here, first one is the catenation property of fifth A group elements are okay. Now these are the lesser than the top that okay. Now this one is the catenation property of what about this one? Fifth A group elements. Now this one is the catenation property of fifth A group elements are the less than that of the catenation property of fourth A group elements. Okay, students. And now here we are talking about that catenation property in that fifth A group elements. Now first of all we should take that fifth A group elements. Okay. And now here we are checking the catenation property of fifth A group elements is very smaller. Okay, students. And now it is really very okay or very much okay or very much smaller catenation property is exhibited by the top. Okay, now smaller catenation property is exhibited by the fifth A group elements comparing that of fourth A group elements. Okay, students. And next one we will check the catenation property within the fifth A group elements. First of all, you have to take that nitrogen element, next in the phosphorus element, next in the arsenic element, next in the nitrogen, phosphorus, arsenic, strontium, and next one is the bismuth element. Okay, students. Now here the bond dissociation enthalpy or bond energy of this one is the 159 kilojoule per mole. Okay, students. Now here bond energy of this one is the 213 okay, students, kilojoule per mole. Now this one is the 157 okay. Now this one is it is 157 like that. Okay, kilojoule per mole. Now here decrease. Okay, students. Now these are the bond energy, that means bond dissociation energy of nitrogen is 159 kilojoule per mole. Now the phosphorus bond energy 213 kilojoule per mole. Arsenic bond energy okay, 157 kilojoule per mole. Okay, now from here to here, now the bond energy completely decreases, friends. Okay, first of all you have to now we should concentration this phenomenon. Now what about the now in these group elements, okay, which element exhibit the more catenation property? Now that means more catenation property means which element can form the more cyclic compounds, which element can form the long chain compounds, which elements can form the double bond, if is there any possibility in double bond compound. Okay, students. Now here if we are talking about that these group elements, now in this one according to okay, depends upon that bond dissociation enthalpy okay, or bond energy according to the bond energy. Now in the fifth A group elements, nitrogen bond energy 159 kilojoule per mole, phosphorus bond energy okay, 213 kilojoule per mole. So here the phosphorus element has the higher bond energy. Okay, students, phosphorus element has the higher bond energy than that of nitrogen. So that's why phosphorus element can form the more compounds. It may be cyclic compounds, it may be open chain compounds, it may be rings, okay, like that. So it is able to form that more compounds. Okay, students. Now what is the reason? Why do the phosphorus element only can form phosphorus element only form that only exhibit the catenation phenomenon? Now actually now we have to take that one. First one is the second period elements, friends, here. So second period elements means lithium and beryllium, boron, carbon, nitrogen, oxygen, next is the fluorine. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So these are the second period elements. Okay, students. So in these in the periodic table, these elements are considered the second period elements. Now these elements are always exhibits the anomalous behavior. Okay. Now what is meant by anomalous behavior? That means anomalous behavior means the lithium group element, that means first A group elements. Now beryllium, second A group elements. Okay, now third group elements, fourth group elements, fifth group elements, sixth group elements, the seventh group elements. Now the beryllium is differ with that respective group elements. Lithium is differ with lithium element behaves as different with that respective group. Beryllium behaves as different with respective group. Boron also different with their group elements. Carbon also different with their group elements. Nitrogen also behaves as different with their group elements. Oxygen also behaves with different group elements. Now here also same. Fluorine also behaves differently with their respective group elements. What is the reason here? Why the second A group elements behaves as differ, or what is the anomalous property of second period elements? Now that means the second period elements are that first one is the very, okay students, very small in size. The size of atom is the very small, okay students. And the next one is the high ionization enthalpy, okay students. So second property is the high ionization enthalpy, and the third one is the high electronegativity character, and the fourth one is the, now that means the absence of d orbital, okay students. So these are the important properties of that second period elements. Due to these period, that means due to exhibited by these properties, they have always behaves with different properties with the respective group elements, students. So that is the main concept. So it depends upon that concept. Actually here, now if we are talking about the nitrogen element, what happens friends here? Nitrogen bond is the, okay now this one is nitrogen bond. Now nitrogen single bond is a, okay friends, nitrogen single bond is a weak bond, okay, comparing with that phosphorus bond. What is the reason here? Due to the absence of d orbital. First concept, due to the absence of d orbital. And the second concept is the now which is undergoes to the top, okay students, which is undergoes to the top inter-electronic repulsion, okay now which is undergoes to the top inter-electronic repulsion. So due to the inter-electronic repulsion, okay students, now it undergoes that weak bond dissociation, and that means if you have to write it like this one, so it has the lone pair of electrons, okay. Now here lone pair repulsion or inter-electronic repulsion is greater in this molecule comparing with that inter-electronic repulsions of phosphorus elements, okay students. Now we have to take that phosphorus element. Now here this is the phosphorus, and next one the phosphorus element. Now it has the lone pair of electron, but here the size of phosphorus element is greater than the top size of nitrogen element. Now nitrogen is the more electronegative element than this one is the comparing this one. Now it is the less electronegative element. Due to the less electronegativity nature and due to the less inter-electronic repulsions, now it undergoes that means it can involve that catenation property. According to that means based on these reasons, now the phosphorus is undergoes that catenation, but nitrogen does not involve that catenation property. Okay, students. Now in this case, now the phosphorus can form that different type of compounds. Okay, but the extension of nitrogen in that so the catenation properties of nitrogen. Now it is a very small extension, okay now it is very small extension of okay students, extension of catenation. Now that can form that first one is the nitrogen bond, and next one is the okay this type of bond will be formed by this, okay now so this is the catenation property of this one, okay. Very small extension of catenation property, very small extension of catenation property of nitrogen element, okay students. Now this is the concept, and next one is we will take, if we will talk about we will talk on that phosphorus element. Now here the phosphorus element can form that these type of compounds, okay students. Now this one double bond, now here CH3 group, and next one the CH3 group, and next one the this type of compound, okay students. And you should take the phosphorus double bond with CH2 group, and here also CH3, and next one the CH3 group, and next one the CH3 group, okay students. And the next molecule is the phosphorus can form that okay. Now what about this one? so C2H5, okay na, triethyl phosphine, and next one is the so phosphorus C6H5 taken 3 times, okay na. Now this one is the now not phosphorus, now we have to take the arsenic elements, okay na. Now these two compounds are acts as ligands, okay students. Now these two compounds which are acts as ligands in that compound, okay students. So these are the ligands. The property of this one is the ligands. Now here this is the only, now it is able to form this type of compounds based on that catenation property. Now it can, it undergoes the top. What about this one students? Here it can form the double bond formation. But here one more thing is the, due to the absence of d orbital in that nitrogen atom, it does not form the d pi bond formation, okay students, d pi bond formation. So d pi bond formation is not possible in that, okay students, not possible in nitrogen element due to absence of d atom. But here in these compounds, that means phosphorus double bond oxygen, okay now, bond with CH3 group, bond with CH3 and bond with CH3. Now here it has the availability of d orbital, okay, but here this one is the availability of p orbital. So it undergoes to the top d pi p pi bond formation, okay students, d pi p pi bond formation. But here are the same thing. Now this one is the p pi bonding, and here it should be the d pi bonding. So it undergoes to the top p pi d pi bond formation is okay na. Now the p pi d pi bond formation is involved in that this type of complex compounds, okay students. But in this case phosphorus is able to form that ligands, okay na, triethyl phosphine, next one the triphenyl arsine, okay na, that means arsenic elements, so that is the arsine compounds. So these are the, these compounds are formed by, form depends upon that nature of catenation property. Now here we will take that catenation property within the group elements, okay now, within the group elements. Now first of all we have to take this one, nitrogen, phosphorus and arsenic, and it's the strontium and it's the bismuth. So now if you have to study the what about this one, catenation property, if you have to check that catenation property in this group, now the catenation property is decreased from phosphorus to, okay na, down, that means bismuth, okay students. Actually catenation property is completely depends upon that okay. Now there is a bond energy, bond energy also decreases from top to bottom. So catenation property also decreases in 50 group elements, okay students, in 50 group elements. So this is the property. And next one is the, now next one we will talk about that catenation property in that 6th group elements, friends. Now here we should take that 6th group elements. So this one is the 6th group, okay. I will write that elements. So first element is the oxygen, sulphur, selenium and next tellurium, and next last one is the polonium, okay students. So these are the 6th group elements: oxygen, sulphur, selenium, tellurium and it's the polonium. So here now how can you check that catenation property in the 6th group elements, friends? Already we know 4th group elements, that means the catenation property is started from the 4th group elements. Carbon element has the highest catenation property in the total entire periodic table. And one more thing is the 5th group elements are, okay na, the catenation property of the 5th group elements are less than that of the 4th group elements. If we have to study the catenation property of 6th group elements, so the catenation property of 6th group elements also lesser than that of the catenation property of 4th group elements. So here first of all we should take these elements: oxygen, sulphur, selenium, tellurium and next the polonium compound, okay, polonium element. Now here, so this is the first element of that group, that means it is present in that 2nd period element, okay students. So it is present in the 2nd period element, okay. So in this 2nd period element now that means this one is a more electronegative atom, okay students. So that means more electronegative element, And one more property is the now that is the absence of d orbital. Okay, na absence of d orbital. Electronegativity, more electronegativity, absence of d orbital, and next one is smaller in size. Okay, the size of atom is the smaller in size, and next one is the high ionization enthalpy. Okay, students. So depends upon these properties. That means electronegativity properties of oxygen is the higher, and next one is the absence of d orbital, smaller in size, and next one the high ionization enthalpy. Okay, students. Now here the catenation property of oxygen, and next the catenation property of sulfur, and next we have to check the catenation property of selenium and tellurium, next the polonium. Okay, in a group from top to bottom, the bottom elements does not exhibit the bottom elements does not show the catenation property. Okay, here now the sulfur has more catenating property. Sulfur exhibit the highest catenation property due to the availability of d orbital. Oxygen does not exhibit the catenation property due to the absence of d orbital. There is no availability of d orbital in that oxygen element. And one more property is the more electronegative element. Okay, students. Now the catenation property especially depends upon that now that is the bond energy. Okay, students. The catenation property depends upon the bond energy. Now here bond energy in a group. Okay, if bond energy in a group from top to bottom decreases. When the bond energy decreases, catenation property also decreases. Okay, students. Now here if you study the catenation property, this one, so lesser catenation property and it has the greater catenation property, and these elements does not exhibit the catenation property. Now that means catenation property of 6A group elements it decrease from sulfur to polonium. Okay, students. Catenation property of 6A group elements decreases from sulfur to polonium element. So this is the important property. That means decreasing the catenation property in a group from sulfur to polonium. It will be clear, students. And next one is the now first of all we want to study about this one. So if you have to check the catenation property of oxygen element, so you should take that oxygen atom. Now the oxygen atom having the two lone pair of electrons. Okay, each oxygen atom having the two lone pair of electrons. Now that means it undergoes that more inter-electronic repulsions will be takes place in between that oxygen atom. For example, if you have to take that sulfur and sulfur element. Okay, students. Now this one is the sulfur element. So comparing with sulfur atoms are greater in size comparing with that oxygen atoms. So here, of course, it has also these are also having that two lone pair of electrons. But here, sulfur atoms also possessing two lone pair of electrons, but there is no that much of repulsions due to the availability of d orbital in the sulfur atom. But here, in case of oxygen atoms are smaller in size and it has the lone pair of electrons and one more is the absence of d orbital. So due to these factors now it undergoes that of inter-electronic repulsions. So that's why it is not able to form that longer chains in between the oxygen atoms. So that means oxygen has the lesser catenation property than that of sulfur atom. But here sulfur has the more catenation tendency to form that different type of compounds. Okay, students. And if you want to if we will study about that structure of that sulfur atoms. Now here sulfur can form the different type of compounds. Now those compounds are that hydrogen sulfide, hydrogen disulfide, hydrogen trisulfide, hydrogen tetrasulfide. Okay, students. And now that means next one is the that is the sulfur containing acids. Okay, sulfur containing sulfonic acid. So first of all we will see that hydrogen sulfide. Okay, students. So this one is the hydrogen sulfide. So first compound is the hydrogen sulfide. So hydrogen sulfide means H2S compound. Okay. Now next one is the hydrogen disulfide. Hydrogen disulfide means hydrogen atom linked with one sulfur and another sulfur next to the atom. And here third one is hydrogen trisulfide. Okay, friends. Third one is the hydrogen trisulfide. So hydrogen, sulfur, 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 and the hydrogen. Yes, friends. And next one is the hydrogen tetrasulfide. Hydrogen tetrasulfide. Now here hydrogen, sulfur, sulfur, sulfur. 1, 2, 3, 4, and it's the hydrogen. Okay, friends. So these are the compounds. Means these compounds are formed by that hydrogen sulfide elements due to the what is the reason now that means sulfur is number of times connected with that same kind of atoms. Okay, now due to the more catenation tendency, so higher the catenation tendency, so it can form that more number of compounds. So hydrogen sulfide, here 2 times the 2 sulfur atoms are present, here 3 sulfur atoms are present, now here 4 sulfur atoms are present. Okay, students, the compound name is the hydrogen sulfide. Now here this one is the dihydrogen hydrogen disulfide. Here hydrogen trisulfide, and here this one is the hydrogen tetrasulfide. And next one is the now that is poly. Okay, sulfonic acids also formed by using the sulfur atoms. So that means polysulfonic acid. Okay, students, okay, sulfonic acids. Now what is the structure for the polysulfonic acid here? Now that is SO3H compound, sulfur atom number of times and SO3H type of compound. Okay, friends. So these are the polysulfonic acid. So that means sulfur present in between the sulfonic acid. Now that is number of times. Okay, friends. N is equal 1, 2, 3. Okay. Now here N is equal to 1, 2, 3, 4, 5, and up to 6 atoms. So 6 atoms may be present in that sulfur. So that's why now these type of compounds are called as polysulfonic acid. Okay, students. So these are called as the polysulfonic acid. But oxygen also able to form that poly. Okay, now that means peroxide compound. Okay, students. Now that one is the peroxide. So peroxide means H2 and it's the O2 compound. So this is the that means polyoxide containing oxide. So now that is the peroxide compound. Okay, friends. Now these are the sulfonic acids, and now these compounds are called as sulfides. Okay, now so this is the catenation property. Now here in this case in sulfur group, that means in that oxygen family. So catenation properties depends upon that bond energy. Okay, friends, bond energy. So greater the bond energy, now the greater the catenation tendency. Okay, lesser the bond energy, lesser the catenation tendency. So that means here if it has the lesser bond energy, so it involves the lesser catenation. That means it link with the lesser number of atoms. Okay, friends. So depends upon the bond energy, catenation property of 6th group elements sharply decrease from that sulfur atom to downward. Okay, na sulfur atom to downward. So this phenomenon is called as catenation phenomenon. If